Yeah, so one topic that was suggested was Ozempic, which I knew very little about, and then I looked it up and saw that in the list of the most valuable European companies, I think by market cap, there was ASML, a bunch of handbag manufacturers and fashion brands, and I forget the name, but the parent company of Ozempic. So apparently in Europe, it's, a big deal. Everywhere the product is a big deal, but the company is a big deal in Europe. Um, do you know anything about it? Presumably, it's one of the things you're sort of paying attention to, but so I'm interested to hear your take on it. And yeah, maybe we can talk about that general side of things. There was also another email I had from a friend of mine reflecting on some of the transhumanist topics, so maybe that will naturally come in.
Sure, sure. Well, so Ozempic is an example of I think it's a little bit too early to know whether or not this is going to be the beginning of a disruptive technology. Now, I've said might have published on it. I think I did publish on it in a paper, an essay, maybe more than one. About I would have to go back and look and double check, but certainly for a decade or more, one of the hallmark sort of quite transformative medical technologies that I've been expecting at some point to arrive and then be enormously impactful is a effectively an eat anything you want and don't get fat medical technology of some sort. And it could be, pharmaceutical intervention, but it could be something else. It's conceivable that you could have some different mechanism by which you achieve that same goal. It's not completely inconceivable you could have a body modification that did that. So, for example, people do get stomach stapling and that sort of thing. So I suppose it's not totally inconceivable you could sort of have some actual hack to your plumbing, maybe, but that seems pretty far-fetched. Another possibility is there might be some alternative to strictly pharmaceutical approaches at the level of the brain, where you could have some sort of, say, for example, there was some intracranial stimulation technology, like, very strong magnetic field in the right part of your brain, and then that just kills appetite for 6 weeks or something like that. And so one could imagine alternatives to a pharmaceutical approach, but I've always thought that, of the approaches that are currently available, in other words, without some crazy breakthroughs in nanotech with, nanobots or whatever, something truly crazy like that, then it would probably end up being one or more drugs. Genetic modification, that sort of thing, I suppose is some maybe another pathway, but I've always figured that it would be some pharmaceutical intervention in the near term if this nut gets cracked, and then what the functionality that the utility that people would really be after would be the capacity to basically two things. The perfect version of this kind of disruptive technology would be you can still eat anything you want. There's no impact of the intervention on your dietary or culinary habits. So it doesn't change your preferences. It doesn't change your intake. You can just eat whatever you want. And it just wipes away the negative consequences. And the main negative consequence of interest being that, you gain weight. Okay, that would be the ideal version. A less ideal version, but still potentially disruptive technology, would be one that modifies your preferences such that you don't eat as much. It changes your habits, and in a very amenable and effortless way, or so it would seem. Again, minimal consequences, negative consequences, and then you would get the result you want, which is that you don't eat enough to become overweight or stay overweight. So those are two quite different things. And I've sort of been expecting one or both of them to arrive for a while now. And the reason why is because as you just mentioned, Dan, the value of a drug like that is astronomical. I mean, literally trillions upon trillions of dollars will go into a drug that will, in one way or another, prevent weight gain or certainly obesity, but ideally allow you to maintain any body weight you choose. Body weight being sort of fat composition. You could think of a BMI index or other measures of how fat you are as being the operative metrics of interest. But if you could, if there were an intervention available that would allow you to choose your body mass index or other way of evaluating how fat you are, and it didn't have terrible side effects, then this is an absolutely gigantic market waiting to be had. And again, you can sort of have these two pathways into that utility, into that value. And so anyway, that's all context. So within that context, my assessment of the these peptide agonists that are now, it's a family of drugs that are now available. The Ozempic is semaglutide, and that is one. It acts on, from my understanding, it acts on one receptor. Tirzepatide acts on two different receptors simultaneously and is a bit more effective. I believe there are ones that are in development that may also work on two or possibly even three different receptors and be even more effective. My general read on this is, number one, they're not effective enough to be properly disruptive, although they get good results, but they're not quite the silver bullet you would want under ideal circumstances. And number two, they do have some pretty nasty side effects, and we don't have a full handle on the long-term side effects that such as they might be. Now, some of those data that are coming in earlier are discouraging. So people who've lost a lot of weight on Ozempic, for example, it looks like in some instances, and this is my understanding from a rough reading of the literature so far. Again, I think it's early days, we don't know for sure, but it does look like people are losing muscle mass, and it might be that they're losing connective tissue and other having important impacts on other parts of their body, not just on fat. And so this is a real problem. I mean, if it's great to lose adipose tissue. It's not great to lose muscle mass. It's certainly not great to have any impact, let alone negative, a serious negative impact on any of the other tissues in your body. So you got to be real cautious about this. So our optimism is very guarded here. This may be the right family, and maybe there are other drugs, or I should say this might be the right approach. This peptide agonist sort of approach might be right, and there may be more effective drugs to be discovered that work better, meaning more of the positive effects and fewer of the negative side effects. Or it could be that this is simply ultimately a dead-end approach that's effective, but there's no way to avoid harm, in the same way that, fossil fuels do give us energy, but there's no practical or realistic way to completely avoid the negative, harmful side effects. And you can iterate on fossil fuels a fair bit, and you can tinker around the edges, but you can't. Ultimately, you need a better technology to give you an ideal energy solution. Fossil fuels are just never going to be that. It could be that these peptide agonists are in that kind of family of technologies that are ultimately a bit of a dead end. So that's my crude take for the moment. It doesn't surprise me at all that there's enormous interest. I think that there is a lot of money to be made selling this as a treatment for people who are so obese that it is the obesity is so harmful on so many levels that they must be treated, and the side effects are worth enduring, and the limited benefits. I mean, semaglutide, Ozempic, those benefits are pretty good. They're pretty darn good. Tirzepatides are approaching really, really good. There's rumors that there are some that are more spectacular. But Ozempic is not quite what I would say is spectacular results, but pretty strong. but there are certainly people who for whom it's life saving, because if you are morbidly obese,
Yeah.
you are in real danger. And so I have no doubt that this will continue to be a very lucrative pharmaceutical product in the absence of something better. But I don't think it qualifies, or even any of the ones that are sort of in waiting in the wings, whether any of them are really the either of those first two ideal technologies that I've been sort of anticipating would eventually arrive. But my hope is that these are early signs of that, and that we will eventually get there. Now, there's one more thing to say, which is that I forgot to mention this, that there could be some approaches that are very effective to for treating obesity that are an unanticipated result, and there are many of these. To my knowledge, this is quite common in the history of medical science, where we're developing a drug for one purpose, and then it turns out or a treatment for one purpose, and it turns out it works really well for something else. I think Viagra is the most famous example of that, where it was originally a drug being investigated for cardiovascular treatments of some kind, and then
really?
Its effects were noted by people who tested it out. Getting some unintended but positive side effects, shall we say?
The sleep-deprived professor reading that set of lab reports had his eyes perk up for sure. Yeah.
Right, exactly. So one of those that is not impossible is if some of the anti-aging, the longevity treatments that are now in very aggressive development, if some of those pan out, it could be that the treatment of obesity, along with the treatment of many other diseases, is sort of a happy byproduct of treating aging. So, I mean, again, it's early days, but there's been, over the last 18 months or so, there's been some exciting research published, and some new theoretical bases of aging proposed that suggest, and some early results in animal models, that suggest reversing aging may be more feasible than we originally imagined. There's quite a strong success for actually reversing the age of cells in the eye, multiple different tissues in the eye, multiple different tissue structures, and that the restoration of function in those eye tissues, so corneal tissue, retinal tissue, and I think there was one more, that the mice did regain vision function because they had their eyes de-aged. They had them rejuvenated. Now, it's not universally true, but as I think many of us know from either direct personal experience or indirect personal experience for friends, some young people can really basically whatever the hell they want and just not get fat, not gain any weight. So it's conceivable that treating aging will treat obesity in the same way that treating aging will treat other age-related illnesses, cancer, diabetes, Alzheimer's. These are diseases of old age that, under certain circumstances, and thankfully usually pretty rare, do strike young people. But for the most part, cancer is something you get when you get old. Alzheimer's is something you get when you get old, et cetera, et cetera. So if you could imagine a therapy that properly rejuvenated people to the equivalent of their 20s, well, many of us were fortunate enough in our 20s to be able to eat more indulgently than we can in our middle age, and so that could be a pathway to an obesity treatment as well. So that's a possibility worth thinking about, and sometimes those unexpected, those fortuitous, those serendipitous pathways, they're hard to predict, but it's not impossible that can happen. So that's just another sort of thought for context.
Yeah, that's very interesting.
Yeah. So anyway, those are all of my thoughts. I don't have anything else concrete or tangible or whatever to add. I doubt these drugs are a disruption, but somebody's going to make an absolute boatload of money selling them in the near term over the next 5 years, probably, I would say at least. And maybe they're a sign that something much better will be coming along. We'll see.
Yeah, maybe let's segue into the general longevity topic, which you already did for us. Yeah, I haven't been following this research closely. I read David Sinclair's book, Lifespan, which came out near Christmas. I don't know if it was last Christmas or the year before. Maybe it was the year before. I found that very interesting. The associated biology, I kind of understand, I think, and the general strategy that's being outlined in that book, which seems to not have actually I don't think the kind of overarching strategy laid out in that book is not actually published, I think, but I read some of the papers involved and I kind of get it, I think. But are you referring to that group's work? I think he's at Harvard. There's obviously a lot of activity in this field and I'm really not paying attention. So the mice model results.
That's the main line of research that I'm aware of that actually has a theoretical basis and some empirical support for the claim that rejuvenation may, very counterintuitively, be a more viable approach to treating aging than the other gerontology approaches that have up until now been under investigation. So there's a lot of money pouring into longevity and age-related gerontology research now. There are some signs that some frontiers of that are promising, but I think we can all understand why it would be a hell of a lot more exciting to and potentially that would translate into just staggering market demand for a viable product that could de-age people who are already old, compared to a still astonishing but not quite as science fiction and spectacular treatment that prevented aging. So, it's one thing to slow down or halt aging. Those would both be astonishing feats in their own right that people would basically pay just anything for. But oh my goodness, if you want to dial it up to 11, beyond that, if you could turn the clock backwards, that would be something else entirely. And Sinclair's group, to my understanding, at Harvard is one of the groups that is, again, as I said, has sort of a theoretical framework. They have a theory of aging and some empirical evidence that's now suggests that rejuvenation is a viable pathway. I don't pretend to understand the details of it. I have a sort of a layman's 35,000 foot view, 60-second abstract kind of understanding of it. The details I don't understand well enough to be able to evaluate the validity of the claims, but my understanding basically from my read of it, and I haven't read Lifespan, but I've read some of the papers and the sort of meta-analyses and meta-reviews of this work. My general understanding is that the cells in the body begin to lose their clear differentiation as they age not because of damage to the DNA itself, but because of damage to the epigenetic mechanism that controls how the DNA in a given cell type is expressed. So the epigenetics is the tooling and the machinery that unspools and spools out the DNA in order to read the code from the DNA in order to express the genes and then produce the proteins and whatever else that the cell in order for the cell to function. So and this makes intuitively, I suppose it makes some sense, right? What is the difference between a blood cell and a nerve cell? They both have the same DNA. Well, the difference between them is that the epigenetic machinery in those different types of cells reads different portions of the DNA and knows what the hell to do with itself via producing proteins in the right, basically functioning based on the instructions that are in the DNA. What would be an analogy? An analogy would be like you have a full cookbook full of recipes, but in order to actually produce an apple pie, you have to be reading the recipe from the apple pie page. It's no good reading the recipe for pesto pasta or 2 lines from the pesto pasta recipe from a completely different page if what you want to make is apple pie. So this is the analogy that different types of cells have very specific readings of this shared DNA. And in this analogy, the DNA would be the whole cookbook, and the epigenetics would be the machinery that tells the cell which portions of it to read in order to cook up the right stuff and function properly. And so anyway, the theory of the Sinclair's group's theory of aging now, to my understanding, is that as cells age, the primary source of dysfunction, which leads to lots of different effects, 6 or 7 different harmful effects, categorically harmful effects, that all of this is ultimately the result of cells no longer doing their jobs correctly. And the reason why they're not doing them correctly is because they're sort of blurring into other cell types because their epigenome is not reading the genome correctly anymore. That's what's gotten damaged over time. And so you have blood cells that are not that. What is an aged blood cell doing? Well, it's no longer acting like a good blood cell. It's starting to act a little bit like a skin cell, and a little bit like a nerve cell, and a little bit like an epithelial cell, a little bit like blah 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 blah. And so this is the theory. And then the argument that follows on from this is, well, if that's what's really causing aging in these different cells and then in aggregate different tissues, and then in aggregate beyond that, still the entire organism. Well, if that's the case, then is there a way to repair the epigenome so that the tissues they go back to reading the DNA correctly in the cell? And what the claim is that they have found a way to reset the epigenome, and that restores youthful function and therefore youthfulness to those cells. And then that's what they claim to have demonstrated in the eyes and the eye cells and the tissues in of the eye, the cells in the tissues of the eye. They claim to have done that in the cells of the eyes of mice. And if it holds true, then this would be astonishing, truly astonishing, right? Because it would mean maybe perhaps there's and they have a proposed delivery mechanism for all of this. I don't know how well the details hold up to scrutiny, but I have a primitive understanding of it. So
it was just a drug that they give to the mice, or it's like
there are two there. So again, here's where Sinclair has a reputation for outlandish claims. So again, you have to be fairly careful with this. But so my understanding is that the original research used a standard method of genetic modification, which is adenoviruses go in and they modify the epigenome or the genome or both. But there's a viral mechanism from gene modification that then allows Yamanaka factors to be turned on and off. And this modification, they not only make the modification, but they make the modification such that it has a trigger. And the trigger is a drug. And the drug they've chosen to trigger that is doxycycline, a pretty standard and safe, although strong, antibiotic. And so the idea is you get this viral genetic modification in the target tissue. And ultimately that would be like every tissue, every cell in your body, if this actually works. And then you're genetically modified with this mechanism in you. And then if you want to roll the clock back for a while, you take doxycycline for a few weeks. That causes the Yamanaka factors to express. When they do that, that repairs the epigenome. And by repairing the epigenome in the cells in your tissues, the cells re-differentiate, start working better. The tissue is rejuvenated, and you de-age. That's the original thinking. Okay, the research that came out a couple of months ago as a possible alternative, again, my understanding is that maybe instead of genetic modification, there's a way to simply trigger the expression of these Yamanaka factors. And again, I don't ask me to explain the details. There might just be a way to do that with a standard drug cocktail instead. So instead of having genetic modification and a tuned pharmaceutical trigger for that genetic modification, then instead you could just take some drugs and they would achieve the same thing. And they made some fanfare about doing a machine learning based search of the known drug space. I don't know how many drugs there are to search in, but thousands. And they found some good candidates, and they're doing testing in that now. So we'll see. And that would be even more impressive, because it would turn out that you could just take a cocktail of standard drugs that are known and understood, and somehow that would magically trigger this de-aging process. If you took 4 or 5 different, and this is where it's starting to sound a little fishy to me. Okay, yeah. If you just take Advil, have some caffeine, take a big dose of metformin, and I don't know, throw in some Viagra for good measure, and then suddenly you start de-aging. I mean, okay, maybe, but color me skeptical. That seems a little fishy to me. But it's. I'm not a biologist. I'm not equipped to evaluate the validity of these theoretical claims, let alone any of the empirical evidence that's there. But their previous approach seemed to produce some quite exciting results in mice. And my understanding is that David Sinclair is now out on the speaking trail again, because they have the rumor is, and again, don't trust rumors, but take it for what it is. The rumor mill is saying that in the years since the mice eye tissue research was done, they've now moved to whole body rejuvenation in several animal models, and the results are starting to look exciting. Okay, wow. So we'll see. The one other thing to commend this, I think, is that if it works in multiple tissues, then there is perhaps some basis for expecting the mechanism to be properly universal, and therefore to translate across species and across into other tissue types. So unlike, there's the old joke that, we can cure cancer in mice, right? But those are hyper-specific treatments, and the nature of cancer and the nature of the treatments is such that they don't generalize. They don't generalize to other cancer types, of which there are hundreds. They don't generalize outside of animal models because, again, the specifics are highly constraining. If it turns out that this theory is correct, then the expectation would be, it's likely to be a properly universal mechanism, and then there would be maybe more to get excited about its potential to work in humans, even if we see it working in mice, which you have to be cautious about. We've gotten excited about promising results in animal models in the past that have proven either ineffective or too dangerous, or with terrible side effects or whatever in humans. So we'll see, but there's that possibility now as well. So again, take all this with a big, big grain of salt. I'm not equipped to evaluate the validity of any of these claims. So.
Yeah, I mean, the overall picture, as I understand it from Sinclair's book, I mean, it's a very information theoretic idea, actually, right? Which is, it's sort of consistent with a view of development, which is pretty popular in biology, where you think of so they use the term cell fate. So when you have a undifferentiated cell, and it needs to decide to become a skin cell, for example. Of course, this is not the usual process by which you're generating skin cells in an adult. That's a process of division. But during development, from the embryo you start off with stem cells or undifferentiated cells, which then go through some pathway, a rather complicated pathway in combination with other cells and mediated by messages between them. And it's like this incredible biomolecular dance by which the undifferentiated cells collectively decide to become various other kinds of cells. And that differentiation process is actually something very much akin to the way we're trying to study how neural networks develop over training. In the research agenda I was sketching last time or the time before. So that process I understand a bit. I'm sort of actively reading that literature, not really in connection with longevity, but I sort of do remember the picture from lifespan as being consistent with a pretty information theoretic reading on that development process, which you can think of as rolling down. There's a famous analogy, Waddington's landscape, where you think of an undifferentiated cell as being at the top of some landscape as a ball, and the development process as being rolling down that landscape. And as it rolls down at various points, there's two possible valleys it could roll into, right? You sort of imagine yourself at the top of a ski slope, and there's a ridge and right in front of you, and to the left there's a valley heading down, and to the right there's a valley heading down. And you can choose. And those choices correspond not immediately to different cell types, but to pathways that eventually, through many more branchings, lead you at the very bottom of the landscape to little wells that correspond to all the possible cell types. You sort of divide and divide and divide, and 2 to the power of 15 or whatever gives you all the different kinds of cells. And yeah, as far as I understand it, cellular reprogramming, or like generating pluripotent stem cells from ordinary cells, kind of consists of finding tricks which get cells to go back up that landscape, or at least that's one way of thinking about it. I think it's maybe, like everything in biology, not a perfect metaphor. That was how people originally thought about what generating stem cells from ordinary skin cells, say, was like. But maybe it's like actually much more complicated than that anyway. Like at the level of the superficial analogy, I think that's correct. And yeah, I mean, from the point of view of like statistical learning theory, which is how we think about neural networks, and I think very few people are thinking about this kind of part of biology with these tools, but it's clear that the landscape at the bottom is not a bunch of little wells that are isolated from one another, right? Where you have this very unique, maybe I'll draw a picture on the board. Forgive me, I have my mouse, but I mean, one picture would be that at the bottom of the landscape, you have just lots of wells like this. And this here corresponds to being skin, and this over here corresponds to being blood. And this barrier here is so steep that it's very unlikely you're going to switch. So you should imagine, you should imagine this in 3 dimensions somehow. So that somewhere up here was the progenitor cell, which could have developed either to become skin or to become blood. I hope that's kind of clear. And it's very unlikely from this picture that you're going to have a blood cell like rise all the way up the landscape. That's a very like energetically suppressed behavior, and then go down the other side and become a skin cell, or vice versa. But this is actually a much too superficial picture. So instead, you should imagine like being a skin cell as being like the operating system of being a skin cell makes use of many subroutines in common with being a blood cell, right? And those different subroutines all have their own configuration. And so really there's like the bottom of the landscape probably is a much more complicated place in which there are kind of paths from being a skin cell to being a blood cell, or at least you can reconfigure little bits and pieces to be in one direction or the other, and there's a lot more flexibility. It's much higher dimensional than this picture, and much more complex. And so it's not really a surprise that sort of just random motion left sufficiently long might cause a drift, and that random motion being division of skin cells. So as I understand the kind of argument in lifespan, it's something like, well, the development process which produces your very first skin cells has a very crisp, sort of platonic ideal skin cell. But then as that skin cell and its brothers and sisters divide over time, that process, I mean, it's not like it's changing your DNA, it's not introducing errors, but the epigenome, which is sort of choosing which subroutines to execute, and it sort of constitutes the identity of that skin cell, which is the sort of result of all these divisions. That information, which is like a bit string, right? Like all the divisions that caused you to become a skin cell, that's information that's separate from your DNA. It's not in your DNA. And that information, the epigenetic information, is like not perfectly preserved by division, and cell damage of various kinds affects it. And there's no automatic mechanism for repairing that is completely reliable, as far as I understand. Not a biologist. And so it's really not surprising, and sort of makes a lot of sense that there's this kind of drift. What I do not really understand is where the information is supposed to come from to repair that drift. So I guess I buy the cause, but I feel like David Sinclair's picture is a little naive. Like, he's a very strong biologist, but the information theoretic story is like, I don't actually think they have a lot of competence in that direction, and it's like just a bit of a fancy thing.
One thing that I've heard him claim, again, I'm unable to evaluate it at all, but one thing that I've heard him claim is that he's, and I think this is a verbatim quote, he says, we're very fortunate, I think it's the actual quote is, we're unbelievably lucky that there is a backup copy of the epigenome, the original epigenome, in each cell.
Mm.
And again, that's the claim. I don't know what the basis of that claim is. You probably, it's just a Google search for a phrasing like that, along with David Sinclair, would probably turn up, the sources of videos or articles or whatever, him actually saying that, and you might be able to chase down the claim, the basis of the claim from there. But that was the first thing that occurred to me too, is okay, well, how is this different from other previous theories of damage to tissues, damage at different levels, and especially damage to, originally I believe the thinking was that DNA itself was suffering damage from imperfect replication. That was leading to aging or dysfunction in cells, but ultimately causing age and age-related consequences at the aggregate level of the organs and tissues, organs, and organism.
I'm just sorry.
Again, like the mechanism would, the question would be, where is the mechanism that preserves the original copy of the information? If there's some sort of information, you can think of it as information or data, you can think of it as knowledge. If there's some information and that is being lost as the result of damage, what is the mechanism by which that is recovered to its original state? And that seems, and again, I feel like one of the first things I think that occurs to anybody who's paying close attention to these claims is that is quite outlandish. And what is, so there you would, it's an extraordinary claim, let's say, in Carl Sagan's terms, and so demands extraordinary evidence. And I've not seen any real discussion of what that evidence is, other than just the remarkable claim that, oh, really good news, guys, there's a backup copy in every cell of the original genome. So, and sorry, and one more thing is, just to stretch it a little bit. Sinclair, I've seen in interviews, his chosen metaphor or analogy, metaphor, I guess, is a scratched CD or DVD. He says that when the DVD gets scratched, the underlying, there's a layer of plastic over the actual over the layer of aluminum that is where the data are actually encoded on a CD and DVD. So the pits that are burned into or pressed into the aluminum layer in a DVD are where the real data is. But there's a superficial protective layer of plastic on top of that. And when DVDs get superficially scratched, it's only the plastic layer that's being damaged, but then the reading mechanism gets thrown off and can't read that. And so it's like polishing the DVDs, smoothing out those scratches in the protective layer, and then the original data is still underneath somewhere preserved. And can then also all you have to do is polish the protective layer, and then the reading mechanism can read the DVD again. This is the analogy that Sinclair uses. I mean, again, I don't know why he's choosing that analogy, or how, whether it's reflective of different key. I don't know. I mean, again, you evaluate it for what it's worth. I don't know what the underlying alleged mechanism is there, but that seems to me to be a quite a strong claim that would need a really pretty extraordinary evidence. So that's sort of a first point of quite serious concern that I have. And then I have another, I think, point of concern also, which is there is an implicit assumption. There's an implicit assumption in the claim that rejuvenation is possible here, that repairing cellular function will automatically lead to the repair or the restoration of tissue function, organ function, and ultimately organism function. So in other words, that interventions and repair at one level of organization will automatically cascade upward through larger levels of organizational scale all the way up to the whole organism. And I'm a little skeptical about that, because I'm totally unequipped to evaluate this, because I'm not a biologist of any, at all, and my knowledge is very limited. But here, let me just speak again by analogy. Let's say you have a complex machine like the engine of a car, right? Over time, that engine gets wear and degradation of its components. But if you took out all of those components and you individually cleaned and polished them, and then you put them back together, that might not necessarily be enough to restore the function of the entire engine. Because you could superficially look like the parts are clean and new and restored, but if you've changed sort of their structure of their relationships to one another, like their tolerances are no longer the same, and there's wiggle and slack where there wasn't originally, and stuff like that, then you can lose function. And so that's probably I'm sorry, it's a crappy analogy in the moment, but apply that to a working tissue, like apply that to a muscle tissue. Okay, you restore the individual cells, but does that automatically restore the youthful structure of muscle fibers and the muscle as a whole, and how the muscle is attached into the connective tissue and the tendons and ligaments, and how the ligaments and tendons attach into the bone? Does all of that get rejuvenated just because you've rejuvenated the individual cells? Or does more macroscopic, larger scale structure matter? And again, I mean, I'm not equipped to evaluate that, but that I'm suspicious on that front as well. I could imagine you could have beautifully youthful cells, but tissues that have become sloppy in their structure and organization, and then you still have some, perhaps not all, but some of the symptoms of age-related decline. So now, again, maybe that's incorrect. Maybe there are just marvelous natural healing mechanisms in mammalian in animal biology, and if the young cells just start working better, they'll automatically basically heal you to full functionality. I don't know. Maybe let's pray that that's the case. But I'm a little bit skeptical on that front as well. Again, I mean, this is my sort of shtick, right? Is questioning, spotting and then drawing out and questioning implicit assumptions that are being made in different situations. It's a big part of what I do. And so that was my first question is, okay, well, what assumptions are being made here? And that was a pretty big one to me, that restoring function at the cellular level is going to automatically lead to the restoration of function at every other level of scale in an organism. And I don't know. I mean, I don't understand enough about biology to know whether that's a valid assumption or not, but it seems to me a big assumption.
Yeah, I mean, I guess that's a question about the nature of aging, and one hypothesis is merely that it is accumulated downstream effects of things that are intrinsically localized to cells. Yeah, I don't have a judgment about that. Yeah, I was just looking through some of the literature from David Sinclair. Yeah, I don't think there actually is an identified hypothetical repository for this epigenetic information. They're just hypothesizing that they do seem to be able to de-age cells according to some meaning of de-age, whether that actually corresponds to the informal content of that term. I think it's a little less clear, but according to some metric, they de-age cells. And if you believe the cause of aging is this sort of entropic effect on epigenetic information, then de-aging means sort of by definition that you have to be restoring that information, and that has to come from somewhere, and therefore that somewhere must exist. So this backup copy is like an inference you make from, if you have a hypothesis that this is the cause of aging and that the observed de-aging effects correspond to a reversal of that, then it is a valid inference that that information needs to be somewhere. But I don't see any evidence directly. That's fun. I mean, the existence of DNA was inferred a long time before it was discovered what the actual molecular basis was. So.
Sure, and I mean, I could imagine reversible damage. I can imagine reversible damage in many systems, as opposed to damage that is fundamentally irreversible. And I suppose, in a sense, that means that information is preserved in systems that are, by their nature, reversibly alterable. So, and I think there's principles in computation and so forth that talk about, whether or not changes are reversible and what that implies, what that entails for loss of and entropy and so forth. So you guys are the experts in all of that sort of stuff. I don't understand that at all, but certainly in lay terms and with a familiarity with other types of systems at different scales and different types of analysis, that's certainly something that we see, which is that a systems of lots of different kinds can undergo changes that affect their functioning, but those changes by their nature are reversible. And so if that's the case, if the changes to the genome are reversible changes, maybe damage is the wrong way to think about it. I mean, damage has a connotation of irreversibility to it. And it could be that that's simply, again, false assumption. It's baggage we're dragging along with the notions that are sort of embedded in words like damage and destruction. There's an implicit sense of irreversibility to words like destruction, right? Whereas disassembly is an example of a word that implies reversibility, because if you disassemble something, there's sort of an implicit connotation that one could reassemble the thing that was disassembled. And perhaps what's going on is that the changes are more like disassembly than like destruction. I take your point that one could infer that's the case if one is seeing results that suggest that, again, presuming one's theory of what's actually going on is correct. So if their theory of this is correct, then the empirical fact that they've seen rejuvenation happen implies that the changes, let's call them instead of damage, that the changes to the epigenome are reversible, that they are not irreversible destruction that would then imply the need for some separate, backup to be called upon to drop in, parachute in, and repair the otherwise irreversible damage that was caused, or something like that. And I mean, I don't know. It's biology. Who knows? For goodness sake, it's. I mean, it's astonishing what could be going on. I mean, there's all kinds of crazy possibilities. I mean, one of which is that you've got zillions of copies of DNA in every cell, right? So are they all bad, or does it only take a few good copies that they're the ones that can be, lead the way to restoration of fire? I mean, I don't know. Who knows? I have no idea. Who knows? It may take a long time.
A vote on what the real skin cell is.
Or we just wait for the artificial superintelligences to figure this all out and tell us what's really going on, right? But at any rate, I think the larger picture is that this is quite an exciting line of medical research that, if it pans out, could it could perform what. We haven't really written this up as a formal concept yet as my team, but internally this is one of our internal ideas that we often it's just one of the tools in the toolbox that we draw upon for understanding technology changes and disruptions and so forth. And one of them, and the name of this concept is end run. So this is it's an end run around a situation or a problem is where you, rather than powering your way through obstacles and step by step and okay, you're facing some challenge or some difficulty, some problem, and you just got to smash your way through all of the barriers that exist in front of you. An end run is where you circumvent the problem in some non-obvious or sneaky or otherwise extraordinary way. You run right around the side into the to the goal. I think of end run in terms of American football, obviously, perhaps not surprising given that I'm American, but one could think of other sports or warfare analogies for the same sort of thing. The idea is that in principle, technological advances do arise that allow us to solve problems or otherwise achieve objectives in ways that circumvent all of the obstacles that were previously insurmountable with older technologies. That does happen. Now, there are technologies that doesn't always happen. It's a feature of certain technological breakthroughs and advances. And it could be that this is one of those cases where treating aging is a technological end run around many, many other medical problems, right? Because so many medical problems are strongly correlated with aging. And I mean, young people just don't get ill and suffer dysfunction in the way that old people do. They just don't. I mean, teenagers, they're practically indestructible by comparison to people who are in their 70s and 80s. And if you could rejuvenate everyone to the flower of youth, then you think of all of the other medical problems you would solve in doing so. You would solve heart disease and cancer and Alzheimer's and arthritis and half of the problems that we probably more than half of all of the expenditure in our medical systems for societies are the result of age-related illnesses that just don't affect people in their teens and 20s, right? That's not to say there aren't problems for young people. There are, of course. But a truly effective anti-aging or especially rejuvenation technology would become the textbook end run technology. It would become the example of doing an end run around zillions of other problems that were previously very, very serious and this is ancient as well, right? I mean, so solving climate change is a big deal, but climate change is a new problem. Greenhouse gas emissions are a new problem. Aging is ancient. Aging is older than our species. Probably we were aware of of dimly as pre-human hominids, that aging, you got old and you stopped working as well and stopped being as vital as you once were, and that sucked. I mean, aging is an ancient thing, so the problems that have been associated with that are truly perennial ones. And yeah, man, doing an end run around all of those other problems would be it would be absolutely staggering, and the amount of suffering that would address and so forth. The knock-on consequences are very difficult to overstate. So it would truly be astonishing if it would be miraculous if conquering aging turned out to be easier than we originally imagined. But we're sort of in an era where that seems to be things seem to be doing that, right? I mean, and one that you've mentioned, Dan, is that we used to think that reasoning was, the pinnacle of human faculty and capacity, and that it would be one of the most challenging and difficult things we could possibly instantiate or replicate in machines. And my understanding is you think that reasoning just isn't that hard, as it turns out, and very unintuitively. And it could be that cracking aging and rejuvenation, maybe 50 years we'll look back and say, you know what, that wasn't that hard. And holy crap, is that going to be a very different world. And a godless transhumanist one, by the way, also, Dan. So suck it.
Yeah, I'll see you on the battlefield, my friend, and your robot arms will be no match for my forest-dwelling, raw organic humans. Yeah. Well, hey, I mean, that's an interesting question, right? I mean, I tell you, you get into your 80s and transhumanism starts to, getting robot arms and knees and hips and cybernetically enhanced memory and stuff like that starts to look pretty good when you're really at the end of old age, the end of the traditional lifespan, and things are really starting to become very difficult, and there's a lot of suffering from dysfunction. Yeah, I think it's interesting.
Again, how many healthy teenagers and 20-year-olds would want to, swap their youthful, perfectly functioning bodies for cybernetic alternatives? That's really quite a different picture. So these as ever, technological advance is complicated and muddy, and there are lots of internal conflicts and contradictions, and so we'll see. It's lots of forces pushing and pulling simultaneously.
Yeah, I had an image in my head just now of the Ents from Lord of the Rings, right? So the Ents represent a kind of change in the status quo that you can sort of get to happen in order to face an insurmountable difficulty, right? So under normal circumstances, you would lose the battle against Sauron in this case. But then, there's this enormously powerful latent force that sort of with the right key can be unlocked and brought to bear. And the Ents also happen to be old. So what I'm thinking about is all the capital that's laying around in the world that we don't usually see because there's just nowhere to put it and no reason to deploy it. But at the first, I guess that's basically what Sinclair is running around doing, calling on the Ents. At the first sign of, I think we're already past that threshold, and that's what a lot of the longevity research we're seeing is about. But at the first sign of, say, AI and some of these epigenetic reprogramming ideas being a viable path towards that, the amount of capital that will flow into that will just be astonishing, right? This is part of what's going to make the next 2 decades so surreal. And I think a lot of people focus on the technological changes, but that will be astonishing. But what will truly be breathtaking, I think people presume that the world is more fixed than it is, not technologically, but just socially and in terms of the way capital is organized and the way social structures are organized. But It's organized that way because we're in a certain equilibrium, right? There's really no point in pulling out $2 trillion from investment in X in order to deploy it into AI and longevity research, because there was no reason to think that would have any marginal impact up until now or tomorrow or 3 weeks from now. But once you start to think, I mean, right now,
Yeah.
maybe Sinclair's stuff is like still pretty speculative, but the instant it tips, and okay, they're starting to use machine learning, and maybe it's, I imagine I'd probably read that paper and be like, yeah, not that impressive. But I think it's going to work, right? I think it's very likely that you get better AI, and if these ideas are even halfway reasonable, that a really solid effort in this direction would pay off within 10 years. Now, I don't have trillions of dollars of capital to deploy, and the people who do don't agree with me yet, but I think they will change their minds soon. And when that happens, right, I think people, especially in a capitalist economy, things can reorganize very fast, right? Basically at the limit of whatever governments allow to happen. But with international capital as currently as strong as it is, the changes, the changes could be very dramatic and very quick in terms of the amount. It's not implausible to imagine efforts well beyond the scale of the Apollo program or the Manhattan Project directed at solving aging purely from private funds, given the scale of international capital and the potential returns to that, right? And we're not seeing that yet, but if people like me are right about what's coming with AI progress and the follow-on effects on biology and every other science, then this is a no-brainer, right? So yeah, I guess I would be on the lookout for the first signs of that.
Yeah, I suspect we're. If we aren't seeing those signs already, they're imminent. We're certainly into the billions, if not tens of billions of dollars of investment in aging, anti-aging, longevity, gerontology research, which is quite extraordinary. We're, of course, as we've all been talking about for months now, there's this titanic explosion of investment in AI, and I'm not sure what general lessons to draw from that. So one certainly that occurs to me is that we just in general suck at predicting how difficult or easy big problems are going to be to solve, because we've experienced surprise in both directions. Problems have turned out in retrospect to be both easier to solve than we originally imagined collectively, and harder. Some problems have turned out to be much harder to solve. So, go back 150 years or 100 years or 150 years, and it seemed like, flying seemed like something that would just be impossible to solve. This is truly a hugely difficult problem to solve. Turns out wasn't that difficult. Even walking on the moon was not as, it took a huge investment, surely, but it wasn't as difficult as one might have imagined. But geez, getting batteries that have really high energy density, approaching liquid, hydrocarbon fuels that are, that perform well under various gases. God, that's been a really, really goddamn hard problem. For a very long time, people originally, it comes and goes. Originally, people thought, well, AI will be an easy problem to solve. We'll have it sorted out. In the 1960s, people, well, Arthur C. Clarke figured, well, we'll have it figured out in a couple of decades. And it turned out to be harder than we imagined. And then we became very jaded. And then suddenly, come 2015, folks like myself are still thinking, well, probably another 50 years before we get to artificial general intelligence. And then suddenly there's a major shift and now it's looking like it's not going to take anywhere near that long. It's the right breakthroughs are made, and the solutions telescope into view very quickly. It could be the case still either way for aging and longevity. Just going back to one thing you said before, Dan, about how quite profound the impacts would be, how much social change there will be as a result of that particular technological advancement. It is, in my previous publications, the artificial general intelligence and aging, anti-aging, I don't even think I said rejuvenation technology, just ending aging. In other words, stopping aging. I listed those two technologies as potential triggers of technological singularity. And the way I have defined singularity in my own work for many years now is in the original sense that Werner Vinge meant, and I think that Kurzweil originally meant. I'm not sure if they've shifted since then, but in the 90s, it really was drawn from the analogy of an event horizon around a physical singularity, a black hole, meaning that what was a technological singularity? It is the horizon beyond which you cannot make any predictions about the future that are meaningful at all. That's what I've always viewed it to be. And it's a metaphor, surely, but what it means is that in this context is that we would expect technological changes to occur such that they render the future so different from today that we cannot really hope to make any meaningful assumptions or claims or inferences or predictions about anything at all, because so much changes. And that's artificial general intelligence and certainly artificial superintelligence. It's pretty clear why you could argue that those will cause such a singularity. Like if artificial superintelligence arose tomorrow, then it would be the height of hubris to think you could predict what the world would be like 10 years from now. And I've again argued in my own work that in publications that successful anti-aging technology would represent something similar because of all of the changes it would cause across society. It would make it very, very difficult to make any meaningful predictions on any really meaningful time frame in the future. So much would change about society and the economy, and just staggering amount of shifts. So it's definitely one of those major heavy-hitting technologies as far as its potential impact on the human condition and humanity's future. It is totally crazy to think that in the span of just a few years, both of those, the prospects for both of those, for artificial general intelligence, AGI, ASI, and not just ending, but possibly, ending aging, but possibly age rejuvenation, de-aging, that both of these all of a sudden seem more plausible, like closer than we originally thought. Maybe it won't take mature nanobot technology that can go in and constantly repair tissue to de-age us, that as Kurzweil originally, imagined, which is like, man, that probably still really is quite a ways away, especially without ASI in the picture to help us develop it. But man, if both of these things turn out to be possible on like a 20-year time horizon or 15-year, I mean, it's crazy. So that's a really quite profound shift in the general futurism landscape. Like if you're in the business of trying to think seriously about the future, our job just got much, much harder, because it's very difficult to make any predictions in the 2040s now, or the 2050s or 2060s or whatever, if you really think it's quite likely we're going to have ASI and or de-aging rejuvenation technology by, say, the mid 2030s or the late 2030s. That is just crazy. And I'm having to rethink my whole view of everything in light of these new changes. And I'm trying to keep a level head, but it's kind of nuts, and I did not think I would be in this position if you'd asked me 5 years ago. No way. I thought those two technologies were decades away.
So here's my prediction for Dr. Door. So you remember this chap, Marx, who went from a descriptive mode of uh, illuminating the nature of capitalism and its effects to a normative mode of fighting on some front to change the equilibrium in some direction. So my prediction for Dr. Door is that your descriptive period is starting to unravel, and that your normative period is on the cusp of arriving.
Oh man, that's funny. I mean, and maybe I'm not alone. I mean, it seems like the descriptive era for AI research and development work is quickly becoming supplanted, and now there are very aggressive calls, as you well know, for normative approaches. We've got to be able to align this thing. We can't just invent this technology and not worry about its valence. We have to. It's got to be safe. It's got to be aligned. It's got to be controllable. Blah 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 blah. And all of that is normative, of course, right? So yeah, it's an abnormal time in what was oh boy, I'm blanking on whose thinking runs into who else is thinking here. So some of it is Thomas Kuhn's thinking about paradigm shifts and sort of normal science under normal conditions, and then you sort of have these periods of transformation where that ceases to be the case. But he's not the only person. I'm mixing thinkers here, I'm sure. But at any rate, the general gist I think I'm reaching for here is that it feels in both of those domains like the era of doing basic research is about to give way to eras of very focused and guided and, as you said, normative research, where we are doing science specifically to achieve technological and ultimately social and economic and other ends. It seemed that for a long time, those practical scientific research agendas for both artificial intelligence and for age-related research, that those seemed a long way off. It was like, well, we research this, and yeah, there's lots and lots of work to do, and it's really interesting, it's very important, but the practical applications are still a long way off because we're not anywhere close to the finish line on either of these things. And boy, does that feel like it's changed in the last couple of years, 2 or 3 years. Now, another more cynical approach here could be that, as global civilization and cultures evolve, maybe in the era of social media and modern news media, maybe people are just kind of twigging to this as a strategy. Maybe Sinclair's group is all just maybe some of it is delusion and maybe some of it is properly dishonest and cynical, but maybe somebody's figured out that you can haul in a lot of investor money if you can convince people that the end is in sight and that we really are in this exciting time. And in fact, maybe we're not. And certainly I've seen cynical takes about individual people like Sam Altman and Elon Musk, about organizations, their organizations, OpenAI and Tesla and so forth, that say, well, that's just what's going on here. It's all bullshit. Yep. It's just hype.
Yeah, it's very interesting. I feel like it's almost like a natural law. So let me try an analogy that'll take some unpacking. But the mass or the electric charge of an electron is what's called renormalized. So you don't actually see the like in some sense, there's a theoretical mass of charge of the electron, but because of its interactions with a sort of, I mean, in the calculations, you sort of, that true charge is screened by a lot of interactions with virtual photons, so that you sort of, in the end, have an effective charge, which is different. And this is sort of a general phenomenon, but it's sort of to do with like the truth being like intermediated by a lot of mess, that you sort of, in the end, you have a collective behavior that's sort of ends up being different than the underlying true thing, which in some sense is then not real. I'm reminded of this when going through this technological transition. There's a true thing that's happening, which is the technology, and, for example, whether it's capable or not of reasoning. But it's almost impossible to talk about this, right? Because on the one hand, you have, like, there really are a lot of grifters out there, and the grifters aren't always on the periphery, right? I'm not saying David Sinclair is a grifter, but his fundraising is sort of independent of whether his ideas are true or not, right? Because they're more a function of the people with money and the story and the surrounding technological progress. And that's true also of OpenAI, right? Like they will raise the money they've raised, whether or not AGI is arriving soon, because they don't know that. We don't know that. And so they have to sort of give a particular view on what's likely to happen, and their opponents will be skeptical. And all of that is like somehow, it's like this, a bit like this cloud of virtual photons around an electron, right? It's sort of like this phenomena that is independent of what the true value is, right? And maybe this is just generally true of technological transitions that are this dramatic. It's that they throw up this surrounding epiphenomena that, like, it becomes very difficult to actually either ascertain what the true thing is or to communicate about it. And I feel like I'm in a rare situation of being able, I think, to independently ascertain a judgment of that. But it's thinking about telling people about it or trying to communicate more clearly about what's going on. It's actually extremely formidable to cut through all of that, because, well, for political reasons, you sort of get drawn to one or either camp, and then you're just spouting propaganda at some level. And the people who might listen to you, of course, they can't tell whether or not you're just one of the propagandists or someone actually with a like a more straightforward take based on the real thing. So it's very interesting that you sort of become unable to see the phenomena exactly at the moment that this transition happens.
Yeah, I think that's a really interesting and powerful way to think about probably extraordinarily promising periods in technological development in general. So I suspect that this, what you've described, generalizes beyond the one or two examples that we're talking about here and now. I'll have to go back and look, and I'll certainly talk to Dr. Brad Libby, our sort of resident historian. He's the person on my team who's done the most work and has the most encyclopedic knowledge of the history of technology disruptions. A few come to mind where I think that there probably were periods of extraordinary hype in the anticipation of achievement of or breakthroughs or just at least achievements of levels of capability that we could see coming in some distance away were going to be remarkably impactful. Probably the Manhattan Project is an example of that. Probably powered flight is an example of that. Probably electricity and artificial lighting with electricity in particular are examples of that. So, and surely there were hype cycles. Surely there was cynicism. Surely there was speculative investing and the bilking of speculative investors and so forth. And so this is probably a human and social phenomenon that is not new. So it would be interesting to go back and look and see what patterns are there to discover. And there's probably some work on this. I mean, the hype cycle itself is a perhaps quasi-formal theoretical explanation for how the public and investors perceive technological advancement in any given domain. But at the same time, there have always been scammers and grifters who make utterly false promises on truly scant evidence. And then some supporters or investors do get duped into supporting those things. So cold fusion is an example of that. And once in a while, I know I'll see something like this, especially in the area of the internet, and I'll get quite interested or excited and think, am I seeing just early evidence? Is there something actually promising here, or is this just nonsense? And fools are being parted from their money. And so cold fusion is an example of something like that. And in general, sort of the proverbial perpetual motion machine, right? This is not a new thing. So yes, there are instances of that. Then I think that's sort of categorically different from instances where there is properly impressive early results, and then the claim is, well, just wait and see where we take this and how much better it gets, and how we can make this so much more effective and practical and cheap, and and so on and so forth. Where something really does show extraordinary promise, and then promises are made about how quickly and skillfully that promise can be realized, right? And so it's one thing to throw $1 trillion of investment at AI before anybody has seen ChatGPT. It's another thing for that to occur after the world has experienced ChatGPT and had its proper holy shit moment, right? The same may be true. I don't know if we're really there with this aging stuff, with the rejuvenation of optical tissue in mice. But I mean, for goodness sake, robust rejuvenation of an old mouse back into a younger mouse will be a holy shit moment in that field for sure. I mean, if it's legitimate and multiple research teams can demonstrably show, yes, we can take a mice that's old and de-age it. Well, Jesus, the doors are going to get blown off the building by that, and yeah, the billions are going to flow for sure. Now, whether or not that means that it's possible on any reasonable time, whether even if we saw that tomorrow, somebody managed to rejuvenate a mice, what does that mean? Does it mean it's just another we can cure cancer in mice and it's going to be decades before it translates into human therapies? Or does it mean that rejuvenating humans is actually around the proverbial corner, just a few years away? Well, we'll see. But I think there is a world of difference between that and sort of, cold fusion grifting and that kind of stuff. Empty promises and vague promises are different from reasonable hopes and aspirations based on very promising early results or demonstrated facts. So I get. I mean, this is where, like, again, a year or two ago, I would have been very much in the maybe some really cool things could happen on a 10 to 15 or 20 year time horizon, but I haven't seen compelling evidence yet enough to get properly excited. Fast forward 2 years, and that ChatGPT moment was amazing. Everything we've been talking about since is been incredible in the AI sphere, and then also in the anti-aging realm. Yeah, it looks like maybe some exciting stuff is about to drop there over the next year or two, and certainly the mice results are exciting. So we'll see. One doesn't want to get one's hopes up and risk them getting dashed, but it does feel like quite an extraordinary moment. And then the one thing that we haven't discussed is sort of the but certainly the I guess it's a unilateral catalytic relationship between AI and anti-aging research and development, or really between AI and everything else. But if advances in artificial intelligence occur much more quickly than we originally anticipated, then that translates almost directly into the acceleration of advances on every other front, right? Because AI is going to be instrumental in the development of basically all, every scientific and technological enterprise at the moment, right? I mean, it's very difficult to make progress in science and technology at this point without the aid of computers. And it's just really difficult. Most of that low-hanging fruit has already been picked. Probably a few extraordinary things still yet to be discovered by the lone tinkerer in their garage. But those days seem to be mostly behind us. I'm open to being wrong about that if you guys have a different view. But it seems to me that the pace of technological advancement will be accelerated and possibly hugely accelerated by major advancements in AI, and especially towards AGI. And so there's a sense in which AI is exciting, not just because it is much closer than perhaps we originally thought, but because everything else, technologically and scientifically, is drawn closer with it than we originally imagined. So that's, pretty crazy.
Agreed. Okay, we'll have to leave it there for today. Thanks, Adam.
Yeah, it's fun one. Very good. We'll speak to you guys soon.